Boom. All right. So can y'all see this okay? So we want to bring in some of these other data sets. So here's the chronic disease. We're also going to bring in the smaller subset, stroke subset. Let me see where all these files are in my repository or my folder. Okay. Greenhouse gas data. So again, I'm just like checking my file explorer on my computer and trying to see where I had put all these um, files since we haven't worked with them yet. Energy and environment. And then I just copy and paste the file name directly into this just to make it easy. Nutrient intake. It's under
The
health.
greenhouse data is under which?
That's under the energy and environment folder. Okay. Ag productivity. Oh, whoops. Guys, stop it. Hold on. I'm gonna go put my dogs outside. Oh. Oh. What? Okay, so greenhouse gas. We've got the subset of chronic disease. We've got the catfish and trout. We also need did we say, Nicholas, we are looking at imports and exports,
Yeah.
right? Okay, and also they had, oh, the farm income data, right? Yes, this takes a while, but the catfish and trout, exports, imports, farm income data, let's get that one. All and then we got nutrient intake, ag productivity. We need that one, right? Still, yeah, okay.
Yeah, NDF.
I got that one. Okay. And then the BRFSS. All right. So I've got my library list up here. I copied it over from yesterday and I added leaflet just now, but I don't think we're going to have time to get into that. But leaflet is going to be one that you'll need if you're going to be doing the maps probably. And then let's go ahead and just bring in tidyr just to make things easy. Okay. Just by the way, there is a way that you can make it to where it doesn't print any of these little messages. If you load your libraries with this command, suppress startup packages, I'll put it in here as a note. Sometimes it can get out of hand. Occasionally, if you're using a lot of different libraries, like sometimes I have a list of like 20 or something. This little message printout can get just real annoying and out of hand. So I'll leave this in the file when I upload this, but you can use this syntax instead of this, to make it not print this thing. Okay, so now we're going to import the data. Let me just see if I do all of this in one go, how much that is. Okay, that's quite a lot. If y'all have, it depends on what kind of computers y'all are on, but I would not recommend uploading all of these or importing all of these data sets at once like I just did. I have a very expensive MacBook that the state bought for me and it has a really good RAM on it, but even mine is it might crash today depending on what we get into. So I would only upload the ones that you either want to follow along with examples on or the ones that these are all y'all's specific data files that y'all told me you want to work on. So just work on the ones that y'all want to if you run into memory issues on your computer. More joining and filtering.
Can you copy the libraries for us?
Yes. Doo-doo-doo. Let me get my chat. My chat's not even open. Oh my gosh. Okay. And then Anaya, I did download your data, or Anicia. Yeah, Renaya, sorry. Renaya, I downloaded your data files from chat. So we'll pull those in. I forgot about that. We'll get those in. I'll get those in just a second because my window is all messed up right now with so many variables. This environment is all clogged up. So let's get going. Okay. So we said that one of the examples joining we would like to do, we've got, let's work on the aquaculture one really quick. So I'd like to figure out how we can join some interesting features from the farm income data. I want to filter out the aquaculture data from the farm income data set so that we can try to incorporate that into the other aquaculture data files for some more interesting analysis. So, filter out aquaculture data from farm income. So we will use the same basic formula syntax from last time. So we've got, I'm going to call this new data frame Aqua Income just to, make it distinct. And basically what we're going to be doing is looking at the income data set or data frame that we just loaded up, and we're going to be filtering out, I'm just going to use Aqua as a string, and then we need to figure out where that lives in the income data set. So I think it is in farm income data. That was under the variable description part one.
Do we have to do all of those load libraries?
Yes, that should be loading the library should always be your first step. And if you miss it, you'll basically start to get error messages that'll say something like the function that you tried to call was not found or was unknown, or it'll give you some kind of error messages that usually indicate um, it thinks that things don't exist that you think should exist that you've been using before. If it is acting like it thinks that you're making stuff up and that the package names or function names that you've called don't exist, that probably means that the library you're trying to use has not been loaded. So you can always go back up to the top. You can run this as many times as you want. It doesn't hurt anything if you just want to rerun it. And as you find new analyses and new packages you want to use, I always go back and update this list at the beginning of my code. And then you can also double check over here in your packages pane in RStudio Desktop. These are all the libraries that I have installed on the computer. And so I can just kind of scroll down and be like, it's telling me that this function is not available, and I can look and see if the box is checked. And so you can actually just check this and it will run the command for you in the console if you need to. But then I usually will copy this and I will go add it up here. Does that make sense? But yeah,
Yes.
loading your libraries should always be what you do before you try to import your data, because this command, read.csv, is actually part of the reader library. So usually you'll have to turn the reader library on before you can even run this read CSV command. Hi, May. Yeah, what's up?
It's telling me that the leaflet package, like there's no leaflet package.
Okay, that means it has not been installed yet. So I would just, on yours, let's just put a hashtag # in front of the leaflet because we don't need that right now. So just do
I tried
that.
installing it, um, and it like gave me, wait, let me try again.
You would have to install it if it's not installed yet, and you would run the command that I just put in chat if you want to do that. And make sure the I is lowercase though. Zoom chat capitalized it just now.
Yeah, when I try to install it, it says object not found.
Yeah. Oh, when that's what happens when you do try to install it.
Yeah.
Okay, well, we don't need leaflet right now. That's the mapping tool. So I would say just pause on that. You can either delete it from your code chunk for now, or just put a # in front of it to comment it out and just load the rest of the libraries because we don't need leaflet right this second.
Okay.
All right, so now we have a new data frame here, Aqua Income, that shows us the year and state and cash receipts value for catfish and trout. And Nicholas, you were mostly interested in catfish, correct?
Yes.
Okay, so what we could do actually, let me change this. We can just choose the catfish from this first column. So the first one is called variable description total. Let's just do that. All right, that should be better. Okay, 150 rows, time series of some states of the catfish receipts. So I did notice when I was looking at this has some weird symbols in this unit description. So we have an amount here that's a dollar amount, but it should be times $1,000. So there's a couple of ways that you can move forward with this. We can either we can transform this column and go ahead and multiply each thing by 1,000 so we have the actual dollar value, or you can just remember, and when you do your visualization or analysis, when you put a graph and you present the information, you can describe it as these numbers are representative of $1,000. Do you want to manipulate this and go ahead and multiply it out, or do you want to leave it the way it is and just remember that it's $1,000 instead of $1 units?
Could we just do the manipulation while we like
Mhm.
have the
Sure. Yeah, let's do that because that might be helpful for others too. So we want to update the amount column to reflect actual total, actual value, and get rid of the unit column. Because I'm afraid, I mean, we won't be working with the unit description, but these little symbols like are going to trip. That's not going to fly. So we can go ahead and make this just multiply all these values times 1,000, and then that will have the actual dollar amounts values for your data here. So I'm going to say aqua income amount equals um I think we can just do like, let me double check, but I think we can just do, I think we can just do it this way. We could use the mutate function probably, but I think we might really be able to just do it like this. Let's see if that works. Yeah, it did. Wow. Oh, Lane, I just saw your Lane, let me know if they don't get your computer account switched over in a second, okay? I just saw it join the waiting room, but somebody should be in there to move it over for us like they did yesterday.
Okay.
Okay, so yeah, that worked. So this was a really easy mathematical operation and we didn't need it to consider any rows differently. So what we did is really just took we're saying we're rewriting over the existing column with each value times 1,000, and it worked. So now these numbers are bigger than what was there. So now we won't have to worry about this unit description, and we'll know that the dollar amounts are exactly what they should be. So I will also note that the farm production or this farm income data is only for a handful of states. So what we can do now,
So the aqua econ data, is it under sales, or because I'm seeing several of them, aqua export, import,
so
catfish.
this is a new data subset that we just took from the farm income data.
Okay, all right.
Yeah, so the farm income data, and then we used this, let me put this in chat, this command to filter out only the observations referring to catfish, and I just called it aqua income. So now I actually
like
need
some
to,
errors?
okay,
Share.
yeah, share your screen, please. Okay, yeah, so no package called, oh wait, okay, incomplete expression. Okay, this might sound crazy, but try removing the parentheses from your second comment where it says update the amount column, parentheses, delete those parentheses around data transformation. Try not to use parentheses. Um, and then also just go ahead and delete the, okay, hold on. I see the issue actually. That like I would avoid parentheses in your annotation. It should be fine, but I don't R is really picky, but I see the problem now. Your first statement, aqua income equals income. If you imported that data file called income, after you have the word catfish, it's incomes. You put a S at the end of it. So those two variables don't match.
Oh, okay.
You see what I'm saying?
Yes.
Did you name it incomes or income?
Um,
Look in your environment pane on the right.
it's farm income data 2025.
That's the name of the variable in your R environment pane on the right, like when you imported it.
Um,
Oh, it's income. Yeah, not plural. Yeah. So just do the change in your after the word catfish. Yeah, delete that S. Try that again. Income not found. Okay, did you import those? Go back up. Run that block where you have the files coming in. Yeah, run that one. Okay, now go down. Oh, okay. Those other files, did they get moved from yesterday or from Wednesday when you were working on them?
like I put them in a folder.
Yeah, so now you'll need to update your code to have that folder name wherever you move the import, export, and catfish data.
Okay.
You see what I'm saying? But as soon as you get that, when you get the file path updated on those three files and you run that chunk again, you should be able to run that next one.
So if I just move them back to the desktop, would it also
Yeah.
fix it?
Yep. Yep.
Okay, I just moved them back.
All right, so try it. Perfect. All right, now go down. You can go ahead and do that catfish filter because we'll need that one. Yeah. Oh. Mm. Okay. So on that one, after the word catfish, you need to update the fish to catfish. So it should say catfish. Yeah. Try that. Now try the next one. Boom. Got it. Okay. So I'm going to share my screen. So now we have a couple of different data elements here. We have the list of only catfish observations from the catfish and trout file that shows where catfish is being raised and the price that it's getting over time. I think this is by state, country and state, maybe. Let's see. 34 levels of geography. So let me see. Just scroll down to the middle. United States. Oh, it's all these different products. Okay, catfish fillets. Interesting. So it's all national data?
Oh, I'm not sure. It didn't like give a description of like the data set.
US, oh, there's some state producer inventories. Okay. So in this data file, we've got producer inventories by state over time. We have sales by the nation. I think it's mostly national data. Okay, so with this, all this in mind, remind me again, Nicholas, what questions you're interested in exploring with these data.
So I wanted to tie in the um research I've been doing on agrivoltaics and seeing how with agrivoltaic farms like it does yield to like more efficiency and different types of crop yields since it's dual use. And I wanted to explore how
Mm,
adding aquaculture into that would also help with um, gaining more yield in those areas of energy and water efficiency and crops.
mm,
So that's kind of what my hypothesis is.
okay. Um, so maybe we need to, if you just want to use catfish as an example, because that's like one of the more common aquaculture, things in places that are having farms in the United States. You know what I mean?
Yeah.
Like the states that would have land farms would probably most be likely to farm catfish. So now what we also need to do is filter out the catfish data from these import and export, and then try to figure out how we can mash all of this together into one usable data frame for you. And then this is not what we have here. We'll not really get at the water consumption, but I think we can find that. I think that there's some other data that we can grab around the environmental aspect, but I'll need some time to kind of think about that for a second. I'll look at that this afternoon, and I will email you or message you on UpSquad when I find something. But for now, let's filter out all the catfish observations from these two files as well, and just put everything in a data frame
Okay.
I have for later. So we want to filter out the catfish observations from imports and exports data.
So I'm having error with getting the catfish from the acquire income. So I don't know that the odd object income not found.
Okay, did you upload? So I uploaded my farm income data as income is the name of my variable. And so if you do that, you should be able to say, so aqua income was the new thing I was creating, but I'm doing that manipulation. The filtering is being done on the income, the original version of the data. So
Okay.
remember the
Okay.
syntax. Let me put this in chat. Okay. So catfish imports, catfish exports. These are all coming from, this one's coming from imports.
Do I name mines? Because my import data was cool.
Your
So do I
import,
do that
huh?
for that data that I imported? The
Mm-hmm.
the word that I used was import and export, not catfish import. So do I put
You can
cat?
call it whatever you want. You don't have to use my same variable names unless you want to be able to easily copy and paste the code that I put in chat. So as long as you can go through and update that yours was called just import and export, right?
Yes.
And I put S's on mine because I wanted to be more specific because we talk a lot about exporting data and importing data into R. So I used an S on the end of mine. You can call it whatever you want. It really doesn't matter. Just make sure that it matches when you're typing in your code here. This would be the version that you used.
Okay.
I mean, but you do want to make you can call this whatever you want. You can just call it the imports or cat import, however you want to, um, you know, name it so that you can easily remember which specific data element, but this is really just kind of temporary because we're going to combine these. But this is not the right column name probably. So imports. Oh, maybe it is commodity description. Yeah, okay. What on earth is going on? I think my mouse battery is on the fritz. Okay. Okay. So now we have, oh, no, 0. Hmm.
Oh, I got an error. It says an argument, grapple, catfish, um, import commodity description was caused by an error.
Okay.
Um,
Hold on one second. Let me try this and then I will stop sharing. Hmm. There's no catfish data in the exports. What? Hmm. Okay. There's no catfish data in the exports. I guess that's so I don't know. Honestly, based on your research question, the imports and exports data may not actually be that relevant. I'm surprised to learn. Oh, okay. So the import regular catfish is not in these at all. This is importing smoked fish under a larger category that includes all of these other fish products. So you may not even need to mess with the imports and exports data, Nicholas. Um,
okay.
but, so basically what we just learned, guys, is like this export data, is not a real thing. So um, that's why it's empty. I'm not going to clean up my whole environment right now, but basically we won't need to. Turns out the exports data has no catfish info and imports is not relevant. I'm just going to make a note. Okay, so Nicholas, right now what we have for you mainly is the catfish, this data. So catfish prices and things over time and some information by state. And then we also have the farm income catfish like sales data essentially. And so now I think to close out your data gap, what we would need to find is something about water consumption. We could look at, there is a lot of info on photovoltaics and solar panels on farms. So we can look at that and maybe look at some correlations by state. I'm just making some notes. I'll think about this a little bit more detail later for you. But at least now we have a couple of data elements that we know we need to look for and a couple ready for you to use. So I'm going to move on and I'm going to actually, you know what? I'm going to clean up my environment.
So do I delete that part too?
Delete what?
The one with the filter out for cat observations,
Yeah,
catfish.
you're not going to need this. So since that didn't work out, you can just delete this from your project. But honestly, I think it's really important to talk about when things go wrong and when things don't work out the way you wanted to, because I think that there's a lot of perceptions about with science, we're always looking for the right answer. And in science, we're really just looking for the answer. And so sometimes the answer is no, or sometimes the answer is we don't know, or there's not enough info or something. So that's why I leave it in here and I will add annotation because I think it's good to have bad examples, like it didn't work the way we thought. But it's up to you for your project purposes. If you're going to use this file that you're working in to generate your presentation, you probably want to delete the code and just don't worry about that data element. And then you
Okay.
can also delete this import statements or the read CSV statements related to those. I'm going to comment mine out because we're not going to use them again. Okay. So let me do something real quick. I'm going to import.
Okay. Thank you.
Yeah, no problem. We'll revisit yours in just a second. I want to get a couple more of these data elements worked out. Um, So for Renaya's, I've got your files in here. Remove these. Take a quick look. Okay. This is remind me what this is? Call center abandonment?
I think that one, yeah, that one's like the Medicaid enrollment.
Okay.
So for that one, like I might use some of the other one, but what I specifically wanted was the state expansion, yes or no, part of that.
Oh, okay. And so you're looking, what question are you interested in connecting these with?
I was going to look at specifically for right now, I wanted to look at the terminations and miscarriages part of each state and then separate it by either if the state was expanded or not for
Okay.
2018 in that specific folder. And
Okay.
then I wanted to look at like the different mean averages between those two categories.
Okay. So essentially, I remember now because you said that you have this column that has the year, but it also has the month, and you wanted to separate this out. Okay.
Yeah, because I was looking specifically for certain states where
Mm-hmm.
it matched up with the pregnancy outcome
Okay.
data.
Mm-hmm. All right. Good deal.
So yeah, and then so like right now, I was looking at the left join, but the issue was like I guess because like the multiple states is trying to attach it like multiple times to each one. So I guess like trying to add it without it repeating as well.
Yeah. Okay. We can do this. So if y'all want to follow along with the exact same files, y'all can download them from the chat. These names are not necessarily meaningful, but it's just a short data file name that we're going to work with, and we're going to perform some manipulations and joining on. So this is one of them is the birth rates, um, pregnancy outcomes data is one of these here. Um, did you happen to look at, hold on one sec. I feel like there's, so I think that there's some info from the social determinants or the BRFSS data set that you might also be interested in. But for now, let's just finish this one combination here. So I think first, what we should do is, let me import these. Okay. So this data is Medicaid. Okay, so expanded Medicaid. Yeah. All right, good. Okay. So we want to really this needs to be your kind of primary data file, and we want to try to pull in this data to this one, I think.
Okay. Okay.
So what we'll do, because that's actually super helpful because we have this column
Yeah, I saw
that we
that one
can
as well. It's the
do
same.
the join
Mhm.
on. Now, the issue is there's going to be multiples. I think this is what you're talking about because these are
Yeah.
the same by each state. So we actually need a new unique identifier in both files. That
Hmm.
what we can do is combine the state abbreviation and the reporting period column to make a new column, and that will be our joining identifier. Okay?
Okay. Okay.
That makes sense?
Hmm.
So what we'll do is basically in Excel, what you would call like a concatenate
Mhm.
function. Let me show you all this. Um, and I do think that it usually works with strings, only with strings. So we may have to convert one of those columns to a string.
Okay.
So okay, it's just doing a C bind. That's probably fine.
Is the C-bind gonna work? I tried doing it like one time, but it said something about like the uneven rows. That was an
Oh,
issue.
yeah. Okay, so it's actually, so the C bind is just for, what we're going to use C bind for is to make this new column in each data set, but
Okay.
you won't be able to C bind the two data frames together because they have different, one has 612 rows and one has 12.
Hmm.
But we can use C bind to make the new data frames,
Okay.
or I mean data column, because it should be only one time period observation for each state.
Yes.
um, with state abbreviation and time period. So in the first one, those are called state dot abbreviation and reporting period.
Hmm.
Mm,
So I have the pregnancy data in already. So the trial one, two, is it the same thing?
the this data set with 612 observations is the Medicaid. Did I put this in the folder, Renaya, or did you find this one yourself?
That's mine because I only have 2018 in there, so that's probably why it's different.
Okay, I found that as well, and I almost put it in there, but I decided not to because it was just from 1 year.
Yeah.
But this is the one you said you did find the other years, right?
Yeah, I have
Oh.
2022 and then I have 2018, but I wanted to try it just with 2018 to see just
Is
how to do it so I have something for my other
does
year.
this one have other years?
No, it doesn't.
They're
Both of them
both
are,
2018.
yeah, both are 2018 only.
Okay. All right. Well, we can easily pull in the other years
Yeah.
before we start. What on earth is my mouse doing, you guys? Oh my gosh. What is happening? Do you have the other years for both?
Yeah, you would have to filter out the Medicaid one because it goes 2017 to 2023, I believe. But yeah, they both have like the same years within them though, for sure.
Okay. Well, honestly, I think it would be easier
Hmm.
to join the years together before we join the data sets together
Okay.
if you want to try that. But if not, that's okay.
Yeah. I wanted to do it. The issue is for the Medicaid data, some of the totals, like are you saying like for 2018, one for 2019, like a average from the months or
Um, so this, what were these called? It's the Medicaid and CHIP enrollment data. Yeah, I saw these in data.gov and they're each listed by, like each year is a separate. Um,
okay.
so when I'm working in here, by the way, I use these filters on data.gov to sort for national data or specifically for CSV files. So let's look at the federal. So we have the pregnancy outcomes. That's the one that I pulled in. Mm, now this is interesting. This might be an interesting thing for you to pull in. I'm gonna leave that open. Hold on. Here we go. Did you already look at this?
Okay, so the one I have is the state Medicaid and CHIP applications,
Which,
eligibility determination enrollment data.
yeah, this one?
Yeah.
Okay, but then also, did you see this one?
Which one?
I'm sure. Am I sharing my screen? Oh my God, am I not?
Yeah, I see. Okay, I see
Okay,
it.
I was like, oh my God, I'm not having tripping. Okay. Yeah, this number of pregnant and postpartum.
Oh, I didn't see that one actually. That actually might be even more helpful.
Is that not the exact same? Is this not the pregnancy outcomes data? Wait a second. Number and percentage of beneficiaries ever pregnant during a year, the number of live births, and the number of adverse outcomes.
Hmm.
Let
Is
me,
that just like more specified?
yeah, I think it's like this is the Medicaid data that is specific to pregnancy. And then we have, this is the pregnancy outcomes.
Okay, I see.
Where did I get that
Oh,
pregnancy
that could be.
data? Pregnancy outcomes. Oh. I do think that yeah, that is for okay. So the pregnancy outcomes data is this is all from the same basic data, but it's presented differently. So this one
Okay.
includes rates per 1,000 beneficiaries. So this is rates, and then this
Oh, okay. That one's like a total.
counts. Yeah, numbers.
Okay.
So I think both might be interesting, but basically for the
Hmm.
question, I think either one could be, the rates is probably more appropriate for comparing state-wise based on
Yeah.
expansion. But it is neat. I didn't realize that we had the number data as well.
Okay.
So let's see. We've got basically what we're going to do is do a C bind on, that is not the right one. We're going to do a C bind on the state name and this here. And then
Hmm.
also, where did the other one go? I have too many Excel windows open. Okay. Then also, we need to use the actual state name, not the abbreviation. So state name and reporting period. That's what we're going to do.
Yes.
All right. State. And then try to ID equals C bind. See if this works. Okay, now it's down here at the end. So many columns. Oh, nope, that did not work. Paste. Okay, cat. I thought it was okay. I thought that there was one that was very similar to just concatenate. Okay, concatenate. I don't think we have to use a string for this. Let's give it a shot instead of C bind. Nope. Hmm. Um, Oh my God, it's copying the whole thing. That's not right. Maybe we do need to use the strings. Okay, so let's try this. Let's try converting it, convert both to strings.
Okay.
And the other way that you could do this is also when you upload the data, when you import the data,
Mhm.
don't use this argument. But since I already did, that's fine. So we can just convert it. Let me close out this output. Okay. So try state equals as string. I think that's the command. No, to string. I get my Python and R stuff mixed up all the time. Okay, yeah, to string. Let's try this. Pretty wild. All this.
Okay.
And I crashed R. Crashed. Hmm. It's a real shame. Let me try to free up some active memory. Much stuff open. Dunzo, you guys. Rebooting. R. Come on. Come on. It's really, I'm about to do like a force stop. Yeah, this is what happens, guys, even on my fancy Mac. Boom. Let's try this again. I don't think I was doing it right anyway. Okay, let's see how far I got. Okay, so wow. This is why we save our work. Okay, libraries. This time I'm just going to import the ones that we were just working on. Now, before I start concatenating, let me try. Or actually, you know what? I'm going to go back and and delete this strings as factors. Do it that way. All right. So now we've got these in here. And those should be strings now. So now we don't need to do this conversion.
Mhm.
But now, why are we having these issues with concatenating? Paste. Let's try this one. Where's my help window? Oh, help. Let's give it a shot. Boom. Now it did put a space in there. That should be okay,
Yeah.
as long as it did it on both of them. Yeah, okay, perfect. So now we have this ID column is going to be our unique identifier to join the two data elements. Okay. So let us check our handy. Where's all of my windows? Nope. There we go. All right. Check this out. So, data wrangling cheat sheet, combining data sets. So now, Renaya, which one do you think we need to use? Let's look at this little chart. So we have two data sets, A and B,
Mhm.
and we are going to use a column.
Sorry for the interruption,
Mhm.
but it is approximately halfway through your session. So when you find a natural stopping point, please take a break, 5 to 15 minutes. Thank you so much.
Thank you. Okay, so now we should have, there's only 12 months in a year, and there are the same number of states. So I think we should be able to do the inner join.
Inner joy. Yeah.
I think. So we're going to give it a shot. What do you want to call the new data set?
You can just, I guess, call it like combined 2018. Yeah. Yeah. And so the inner join, what is it? It joins which part of the data?
So it's going to join both of the data sets. Well, actually, yeah. So we don't have the same number of rows. Hold on a second. We've got this. Why do we not have the same? We have 2018 because there's a lot more. So actually what we need to do, this needs to be the primary, and we're going to try to merge this smaller one into this, I think. Let me think about this. Let's actually try. Yeah, the inner join is actually not going to work. So we need to do either a full or one of the left or rights. It doesn't really matter. Let's just try a left or right, because the full join could end up adding a whole bunch of rows with missing values that we don't want. So we have more rows on this try two data set, and we have more columns on the other data set, but you're really only interested in a couple of these columns, right?
Yeah.
So which, I know you have the expanded, but are there any, like you don't need the final report Do you want to
No,
read any of these other applications
I
or
don't need any of the applications. The only thing I would probably be looking at is like the total CHIP and Medicaid enrollment list. There was like multiple, so I have to see which one I want because
yeah,
I think one's cumulative and then one's monthly.
okay. Total determinations, enrollment. Okay, so let's actually just take a few of these. Um, let's make a new data set like we did yesterday or Wednesday with hold on. So let's actually make a new data frame and shrink down this one to the columns of interest.
Okay.
So this is what we did. Where was it? Here we go. Uh-huh. Okay. So we're going to say enrollment is the new thing equals, we definitely need the state. Oh, and we will have to make a new empty matrix. Okay, equals data frame, and we're going to have no columns, but we're going to have 612 rows in our empty matrix that we're going to populate with these new columns that we're defining. So we want this date, we want the reporting period. We're going to want the ID, unique identifier. We're going to want the expanded status. And then you said also you want total determinations, child enrollment, total enrollment, Medicaid and CHIP, et cetera. Which of these?
I'm pretty sure I just want the enrollments, maybe
Okay.
determinations. I'm not sure if I want to bring that in yet.
So Medicaid and CHIP or just Medicaid?
Medicaid and CHIP, because the pregnancy outcomes is both as well. So I just might as well do both.
Okay. Medicaid, total Medicaid and CHIP enrollment. Date expanding. Reporting period. Okay, anything else?
Um, I think that's it.
Okay. Mm. Oh, whoops. That's where I messed up. Okay. So here's what I'm going to paste this in chat in case this is helpful to others. So now we have this new data frame that only has 5 columns of interest in it. And now this is going to be the one that we pull into this other data frame. So this try to is going to be our A in this example. And then this new enrollment data frame is going to be our B example. So this is where, see this top one, the left join, where it shows we have A, we want to preserve all of the data in A. And then
Mhm.
where matches are available, we want to pull them in from the data in B.
Okay.
So we're going
Yeah.
to do the left join. So now we are going to say all 2018 equals left join. And it should be pretty straightforward. So A is the try to, B is the enrollment. And then we're going to tell the by and the column name. You can also specify a column index number if you want. in this case, you can use the column name as long as you're certain that the column names are shared. So now we have a new data frame here that has 1,272 rows. So it preserved all of the observations from this data element, and then it brought in additional data elements based on the enrollment information. So let's see what this looks like. Can I make my window bigger? Okay. So we've got date, year, month, pregnancy outcome, count, and rates. And then we have state, period, expansion, status, and total enrollment data in one data file.
Okay.
So you could do this basically if you want to pull in the other years later. What you'll do is append all of the years data sets into one using rbind.
Mm-hmm.
And then you could perform this exact same manipulation after you have all of the years appended on both data sets. But we can take a look at that later. But I think this is a good, let's take a pause. We're going to take a short break. I'm going to stop sharing. Those of you who do not need any help right now, please go take a quick bio break and be back in like 5 or 10 minutes max. And then those of you who would like some help troubleshooting, y'all stay on and let me know in chat who needs some help.
Okay, and could you copy and paste that section? My R froze for a second, so
Yes, which
I have
section?
to.
This one?
I have the two string parts, so just after that, that's where it froze, the paste part.
Okay. There we go. Chat. So check chat.
Thank you. Thank you.
Okay. How's everybody feeling? Did this help anyone? Does anyone have any questions on data merging and data joining?
I could use some help.
Okay. Yeah, what's up?
So I emailed you um, the copy of the binge drinking by county. So if you could check your email.
Pizza rat.
Oh yeah, that was me. Um, so
Okay.
it's our alcohol combined, and it tells me it's pretty basic. It tells me the Arkansas County, the population, the number of binge drinkers,
Mm-hmm.
and the percent and the year.
Okay.
So would I be able to merge that with the tornadoes document?
Yeah, let me pull up the tornado one and see.
Do you still have it?
Yeah, I save everything. You never know when you might need it. Okay, so tornado data. Where did you find this drinking data? Department of
From
Health?
the department. Yeah, Arkansas Department of Health.
Okay. And it's just for 3 years, but it is by county. So nice time series. And then in the tornado data, we've got other states. Let me see how many Arkansas observations we've got here. So 48 rows. Um, Oddly enough, all from 2010. What's that about? Hold on one second.
Oh, so it doesn't match up.
How did we? Is all of the storm data just from 2010?
Yeah, I didn't notice that. That's weird. Okay. Well, in that case, let's pivot and just drop the alcohol completely.
All the storm data is from 2010. What is that about?
Is
What
that for
do you-
every month?
Yeah, hold on. Let's look at the let me take a look at the MDAT database. Let me see how many tornadoes we have. In this other data set. All right, we have in the other data set, there are 160 observations of tornadoes, but only a few of them are specific to Arkansas. So yeah, I mean, there's a couple of different options here, Lane. I think, pivoting is definitely going to be, we'll have to get a little creative and think about how to proceed. But, we have a lot of storm data. We do have in the BRFSS data, I think. I'm pulling it up. Let me see.
Okay.
I think we have. Oh no, we did pull out the alcohol stuff from the chronic disease indicators, but what was that? That's by state and by year. So I guess there's a couple of different options here. You can expand your the tornado idea and say you want to look at trends in drinking after um some sort of, you can just define how you want to define it, but like a communal trauma of some sort. So like either these, the MDAT database has a lot of other types of emergencies. So you could link not just tornadoes, but either all storms, all climate disasters, or, there's even man-made disasters like explosions and things like that. So if you're really interested in the link between drinking and like mental, or communal stress, community stress, then I think we can still do that by expanding the purview past tornadoes. If you're really interested in the tornado angle, then I think we need to explore a different relationship of like, or find some different data to support, um, you know, mental health around the storms that we can specifically pinpoint.
I mean, I'm more interested in the tornado,
Okay.
but like Dr. Rafi's suggested something like, are tornadoes getting more intense over time or something like that. But I mean, that just doesn't interest me as much. I don't
Mm-hmm.
know. I would like to connect it with something.
Mm-hmm.
It's just the matter of finding the data.
Mm-hmm.
But at this point, I'm willing to do just like something basic with tornadoes. Like, are they increasing or does time on the ground correlate to crop damage? There's one I was interested in also. It's like there's crop damage on tornadoes and like using the nutrition data to see if crop damage from tornadoes is associated
Mm-hmm.
with health outcomes. I don't know. I might be like making it more complicated on myself than necessary.
I mean, the issue is, I think that so if we're looking at in the weather folder, like the environmental or extreme events folder, we have this, let me share my screen. And then let's talk about this for just a second, and then we can troubleshoot some more in the help desk. So the others, we can make some
Okay.
progress. But, okay, so this is the MDAT database, and specific to tornadoes, we have 389 or 388 records of tornadoes in the United States over time. So this goes back to 1900. Um, why are they not? Why are they not filtered? Thought I filtered. Tornadoes. Tornado data goes back to 1903. And so I don't know if you can see this well on your screen, but we've got
Yeah.
the tornado, we've got the states that were impacted as a string, or sometimes the communities. And the there is a duration here, which might be interesting for what you're interested in. Death counts, injury counts, a lot of missing data there, but there is some data. Damages, estimated damages, value, and should be where is there no magnitude?
Somewhere.
But basically, so there's that information. And then in the storm events, I'm so surprised that this was only 2010. I didn't even realize that. I'm trying to think of where I got this. If there's other, oh, I didn't even put it in there. Great. I think I got it from this NOAA website. Hmm. Yeah, we're gonna have to poke around. Let me send you the link to this NOAA website that has a lot of data resources. And Lane, if you want to spend a few minutes perusing that and see if you can find any other relevant data sets, and then we'll revisit in help desk, okay?
All right, what am I looking for? Like
I just put
variables?
Yeah, well, I just put a link in chat, and it's to the NOAA database website that has, it's like they have more stuff on there. If you look in data.gov, it will send you to this website to download the actual data files. So if you want to
Mhm.
just look through that website that I have pulled up right here and just kind of see, like I just searched tornadoes and it has this climatological summary data, but you may be able to poke around and try to find other
More recent
data
tornado
sets.
data?
Huh? Yes.
Like more recent tornado data?
Yes. Mm-hmm.
Okay.
Yeah. So see what you can find. Okay. So everybody back. Let me take a quick look at my thing. I want to do really quickly, I want to try to hit that multiple linear regression on the NDF data set, Nathan's data frame that we made out of the chronic disease indicators. And then I'm going to put together a classification lab notebook for you guys, and I'll upload it in the folder, but we'll work a little bit with that on um, Monday and Tuesday. Because I think, let me check the schedule again. Yeah, you're not doing any coding on Monday, but on Tuesday we'll pick back up with categorical data classification and machine learning. But for now, I want to do the multiple linear regression. Want this data set. And then Jaime, we can play around with the greenhouse gas data time series. I want to tackle that with you as well. We have time. Okay. So we've got this data set that has the state and some population information, and then also the prevalence for high blood pressure, high cholesterol, obesity, and stroke. So from earlier, Terpase, you mentioned you were interested in this too. So we're going to say stroke is going to be our response that we're going to look at, and then these other three or four can be potential predictors. So So I'm just going to go ahead and say y equals and assign the y as the stroke variable. And then our ISLR textbook will have some great examples of multiple regression. If you guys want to refer to this, where is my navigation?
This document is from where?
This is the textbook that
Okay.
yeah, put in our folder. It's the ISLR Intro to Statistical Learning in R. So there is a section in here, but basically it's the same kind of formula for a simple linear regression using multiple predictors. And it will use the least squares method, which hopefully y'all discussed a little bit yesterday, but it's the same type of syntax. And the way that you can do this, there's a couple of different options, but this is the cleanest format considering the data also has categorical data in it. If you had no text data, like no strings whatsoever, if every single column was numeric and was an actual number and not like a numbered category disguised as a number, but say you had only, if you got rid of the first three columns here, you could run a regression with all of these using a syntax. Oh my gosh, that was almost crazy bad. Okay, this is driving me bananas, you guys. All right. So there's a couple of different ways to do this where you're going to fit the linear model, LM for linear model. And this is going to be your Y. And then you use the little tilde wavy hyphen. And normally it would be Y tilde X is the formula, and then assign your data, right? But when you're doing multiple, there's a couple of ways you can do it. X1 plus X2 plus X3, etc. That's if you have some columns in there that you don't want it to look at. So we can't do linear regression, these simple linear models on the categorical data. So that's what we're going to do. But another option would be I'll put this in here as a note just so y'all have it. R has a feature where you can say Y or the response and then tilde, wavy hyphen, and then an asterisk. And the asterisk means it will use every other column in your data frame as a predictor. So the asterisk means everything except Y. So that's what I was saying. If you deleted the first three columns of this, you could do it this way. Or if you have a data frame that is all numeric and you don't have to worry about, categories and stuff in there. But this right here, the second one is going to be the one that we use. So LM1 is what I'm going to call it, equals LM, assign the linear model, Y, which we already named. But we did not name the X1, X2, and X3. So you could have done that by saying X1, etc. But you can also do it by specifying the column names. So high blood pressure, high cholesterol, and obesity. Oh, whoops, plus, not comma, plus, plus. Okay, and then we're gonna say data equals India. Let's see if this works. There we go. All right. So now let's check out the results. Oh my gosh, hold on. It just started dumping rain. Um, So the textbook, they always do this like summary right out of the gate. You can do that. It will show you the coefficients and everything. And there's a lot of, the reason I like to refer to this is there's a lot of information about what all of these different things in the printouts are telling you. Let's go ahead and take a look at the summary and just see what it looks like. All right, so here's our intercept, the y-intercept for this line. Remember in the lab, hopefully y'all covered that this is literally a linear regression is going to give you the line that's like y equals mx plus b, like taking it back to the old school, algebra. Um, let's see, residual standard error here. We have the p-values for each of these three predictors in this table right here. They're all very low. And we have our R squared value. Do you guys know, did y'all talk about R squared yesterday?
Yeah,
So do you want the R squared value to be high or low?
high.
Mm-hmm. As close to
It
what?
tells you what percent is it fits it. Like what percent of the independent
Mm-hmm.
variables fits the dependent.
So is
Like
this
what
a
explains it.
good value or bad value?
That's good.
Mm-hmm. It is good. Let's take a look at a quick plot. And if we want to do, whoops. So we've got plotting multiple continuous variables, right? So I would say we may want to, I mean, let's just do a scatter plot for each of the three predictors by themselves. So we've got, let's do X equals, on the first one, we'll do the blood pressure. And then we'll do one for high cholesterol and obesity. Okay, just really quick, let's get a look at these. So yeah, this one showed a really clear distribution. We looked at that. I'm assuming that's what y'all used in the example. Here's the high cholesterol. So a little bit more spread on this one, just looking visually again. And then this one, okay, obesity. So now we can take the regression line, and you can either manually use the coefficients and intercept to program the to add the line to the plot. Did y'all do this yesterday, adding the regression line?
Yes.
Yeah,
Okay. And I think you can just say, I think you can, yeah, you can just call the model. Okay. So let's add, nope, plot new has not been called yet. Hmm. Yeah, that's not using ggplot. Um, where did that just go? Oh, regression. That's just using, it's not using ggplot. All right, so here's our regression line on just the obesity. So pretty good, right? There are ways to plot all of these three predictors together that we will work on more in the visualization section. But at this point, I think we have fit the multiple regression that seems to have a good explanation of the data. So we're going to stop on this example here. And I hope that that was helpful, Nathan and Terpase. I will put here's the code for fitting the model. And then it is 11 o'clock. What time are they going to kick us out of this room? Oh, 11:45. Great. Okay, so we do have time. Okay. So any questions on this before we move on to another example? Multiple linear regression. That was a really clean version. I think we all kind of assumed that there was a connection between these things. Any other questions on this?
What all packages do you have to install in order to do the regression?
This one is ISLR2.
Is what?
That's the package for doing that regression, the LM linear model.
Can you show me?
Yes, I just put the name of it in chat, the package name, but you'll just do, if you haven't installed it, you'll do install packages. I'm typing it in chat. And
Is it why do you check for the type of plots that you want?
okay, what kind of plot are you wanting to look at?
Yeah, it's just about I want to plot a kind of line for all the variables according to states.
All right,
Like
if you're going
what?
to do it by state, I really would recommend doing a map of some sort, just because having 50 bars or 50 lines on a chart is like visually very, very hard to interpret.
I don't. Is a line a line that I want, not a bar.
Yeah,
Like
but 50 lines, like I said, I mean, you can choose a handful of states to highlight.
yeah.
Like 50 lines is going to get like so busy that you visually won't be able to interpret very much information. You know what I'm
Okay.
saying?
So yeah. So what about box plot? Like the mean of obesity for each state?
Yeah, I mean, you're going to have 50 little box bars.
Oh
You know
yeah.
what I'm saying?
Yeah, I got that.
So I think if you wanted to, there are other ways. For example, you could numerically combine, transform this to combine these three predictors into one feature that would be representative of all of those, and then graph that against the stroke in one plot, against the stroke prevalence in one plot, and then you could plot this regression line over it. I think that would be an interesting way to look at all of them. Or you could, I mean, you can do the small multiples. It's just you're going to have 50 small little plots for each state. You could pick out a handful of states that you're interested in and plot, 10 of those states. Or you could even, if you want to be, scientific about it, you could look at the data and say, find the 10 states that have the highest stroke prevalence or the 10 states that have the highest high blood pressure prevalence and choose those. You know what I mean? It's up to you how you want to make the determination, but I would not recommend plotting all 50 states on anything other than a map.
Okay. Okay. So to look for the 10 state with the highest, I'll need to do the mean of obesity for each state.
You can actually use the summarizing and kind of some of the data wrangling that we looked at yesterday.
Okay.
So
Okay.
one thing that you could do is make a summary for each state. So if we look at this data, we have the states here, and then we have counties, right?
Yeah.
So basically what you can do is condense all of the county-wise data into one, basically condense this to where you have one row for each state. And then you can see what are the 10, filter out the 10 states with the highest values in any particular column using the subsetting. Where is it? Subset variables here and subset observations. So you can actually subset specific rows by position. So you can sort the data from descending order of any of these numbers that you're interested in.
Okay.
And then, why do I keep pulling this up? There we go. And then subset the top 10 rows. You can do it that way, or you can do it by this grouping, summarize and grouping. And you can use maximum value to find the max instead of mean or median. And you can use min to find the minimum. So if you want to look where the lowest stroke prevalence is or something like that.
Okay. Where do we get the plot cheat code?
These are all in the R folder. I'll put the link to this again in chat in the student binder. Okay. So I want to do a quick, let's see. Yeah, Nicholas, on your question, you can keep exploring on the fish data that we have, the catfish thing that we filtered out from the catfish and trout file. But then I think either that or if you want to start looking for in data.gov. I'm going to put a link in chat, Nicholas, for the search for photovoltaic data sets in data.gov. If you want to poke through there and see if any of these look interesting that you want to try to pull in. Okay, take a moment to do that.
Okay.
And then I would like to let's look at the greenhouse gas data. So, hi May, are you there?
Yes, I'm right here.
Okay. So, with this greenhouse gas data, you said that you were interested in doing time series and that you were working on something. Do you feel comfortable sharing your screen to show me where you got?
Yeah, there will be a bunch of like um code that was like left halfway through, but
That's fine.
okay.
You can comment that stuff out for easy if it's harder for you to find things in there, but yeah, I don't care. It's
Oh,
fine.
there's really just one section that was like that I advanced the most on.
Sure.
Um, Let me find my. Oh, it's in another window. Okay. Let me just. Okay.
So this, are you interested in the greenhouse gases from all sources?
Um, yeah, I was trying to filter them by like for this one I oh not for this one. I was trying to filter them by econ sector and by category.
Okay.
Um, and this one I just did it like with the whole thing.
Mhm.
Um, and Dr. Dodd said it would be best to do it by like with averages. But this is just like with random values. Like, um, I like looked at the code in the notebook that you shared with us, but it didn't really make sense to me. Like I didn't really know how to put my data in there.
Oh,
Um, so I went on Stack Overflow and like I found kind of like template code and I was just putting stuff in and like I got a graph out, but it does take a random value, so it looks different every time I run it.
okay. So you're looking at the electric power industry, econ sector, and the CO2 specifically?
I'm not right now. That was just one of my but I can try to do that one
Well, I
specifically.
think what Dr. Dodd was probably getting at is like this is a pretty large data set. And so we have information by state. Again, same applies to what I was just telling Terpase is like if you're looking at data by state, I would encourage you to do that via a map, which I think you mentioned you were working on, and we can certainly take a look at that. And you could even do ultimately if you wanted to maybe a cool little time series animated map that would show the changes over the years of time. But for now, I think what she was trying to say is you do need to summarize if you're talking about, say, for example, all CO2 from all industry sources, or even CO2 broken out by industry sector over time,
Hmm.
would be fine. The issue with some of the time series, the functions that you might want to use are that you may have to start bringing in the time and date packages to create specific time data types. Just like there's a string or a character or a factor, there are very specific um, data types for dates and times, and you have to have a package usually called lubridate to get that.
I
So
think I installed that.
lubridate, okay.
Let's see.
So, Lubridate is a really comprehensive package for dealing with time data in R. Which of these time series plots were you kind of looking at? Do you want to try to just do a basic one?
Yeah, I was looking at the like R graph website. Um, and I think I clicked on the basic one, but it has like, like the specific data types. Um, I think there's a different one.
Okay.
It's not the basic one that I looked at, but let me see.
we can look at, let's just try a line chart first on, or actually, you want to try a grouped line chart and we can have lines for different either industry sectors or gases?
Yeah, that's fine.
Okay, let's try that. So
Oh, I
we're,
tried the time frame. Sorry.
yeah, okay. Let's not, if you look at the time series, I don't think we really need to mess with the time at first. The only reason you might want to do that is to have a clean, label, but we can always mess with that in a little bit. So right now it looks like in this we have 8 economic sectors. We have 7 categories of greenhouse gases. So would you rather have different lines for the greenhouse gas categories or different lines for the sector?
Um, Probably for the sector since I was mainly trying to do carbon dioxide.
Okay. All right. So we're going to look at the CO2 emissions over time. I'm going to, just because this is such a large data set, I'm going to go ahead and filter out only the CO2 observations from this GHG category column. Okay, so first, filter out CO2 observations. So we're going to say CO2 equals, and then we're looking at the GHG data. We're going to filter out CO2 from the category column. Okay. Oh, no. Hmm.
Can you share your screen?
Oh, am I not? Oh my God. Thank you for saying that, y'all. I'm so sorry. Okay. So it gave me it through an error, and I was just looking at what I think the error might be. Error in the grepl is these. Well, these are factors. Yeah, so this is saying it's invalid for an atomic vector. Did I im I did import the data.
I'm not doing it the same way, but it works for me. I'm just doing the filter function.
Okay. What did you do?
I'll copy and paste it into the chat. I'm doing it with the pipe thing.
Huh. Okay.
Oh, I'm doing the pipe, so like I'm doing data type, I mean data like the data name and then pipe and then the line underneath
There we go. All
with
right.
the
So 9,550. It says 51. Okay, yeah, that should be good. Okay, so now let's make a new code chunk and we are going to generate multiple line plot. So basically what we will do, this is a ggplot bar and it's pretty simple compared to like this is pretty straightforward. I think that we've done so far. And so basically what we're going to do is our X will be the sector. No, the X, hold on.
Shouldn't it be the year?
Yeah, now I see what the issue is here. We actually
Yeah.
need to reshape this data. We need to reshape the data.
I did it with I saw like a bunch of posts on Stack Overflow were having it do it like with the data frame. Like you would have to define the data frame.
Mm-hmm. Yeah, so this is where now I see what you were. Okay, so if we look at the data wrangling, basically what we need to do, we have this wide data, right?
Mm-hmm.
We need to reshape it like this to where all of our years are in one column so that we can plot that. So this
Okay.
is called gathering. We're going to gather the data. Do you see this on the cheat sheet?
Yes, I was thinking of doing that, but I was a little bit confused because like wouldn't there be too many rows? Or I
Um,
mean
let's
columns?
just see how it looks. Yeah, it's going to make it a lot longer, but it doesn't really matter how long it is. All we need to know is that we've put all of the year columns together in one thing. So let's pull up our help window for gather and see what information we can get. So gathering columns into a key value pair. All right, so the data that we're going to do it on is going to be um, is there an example to show us? Yeah, gather. And then the key is going to be the names of the new key and value columns as strings or symbols. So the names of the new columns that we are going to call it. So key equals year, right? Isn't that what they did in the example over here, actually? Yeah. Year, value equals, I think, value. Right. And then it's saying the next ones are the um, 2 to 4. What is this range? Sequence. Okay, start and end. Okay. So let's try, if we're looking at the CO2 data, these are columns. We have 1, 2, 3, 4, 5, 6, 7, 8, 9,
I think
10,
it's like 19 to
15, 16, 17, 18, 19 through what?
51.
Okay. So you already tried this
I think so.
and did it work?
Uh I'm not sure I did it right, so we can keep going, I guess.
Boom. Look. So
Okay.
this is what we just made. I'm going to drop some of these columns though. We haven't used that feature or that function yet. I haven't showed that to y'all yet. And this has a lot of empty columns and data that's not going to be relevant. So we're going to drop a few columns before we move on. And then we're also going to clean up this year column and remove the letter Y from it. And then we will do a plot. That worked.
I have I have a version of the data that is just my numbers. Like I went on my like numbers app and I deleted like all the um all the categorical variables basically, and I just left the years and the values.
Mhm.
Would it be okay to use that?
Why don't do you want to show me real quick? I mean, you can use whatever you want. But why don't you show me real quick if you want
I'm
to show
trying
me?
to do my arm. Okay. Oh, I always forget to press the share button. Um, but yeah, I have just the years and like the values. And then I have the one that's the whole thing. But yeah, I don't know if this would work.
Um, I mean, it will, like, that's not going to be easy to plot with the years being the X axis. But what are the rows? Like, if you deleted all the categorical data, how do you know what the rows are?
Oh, because I was thinking, oh actually, yeah. I would
You
need
don't know
that.
which states and stuff are which anymore, right?
Yeah, I would probably need that.
Yeah, I think you need to do it this way, reshaping it. Um, and then
Okay.
we can drop some of the columns that you don't need. But now that we have, since this gather function worked, we should be easily able to plot it now. So let's try to get this example wrapped up before they kick us out. So you can drop columns by index number, or you can use a drop column function, but I'm just going to use the index number for right now. So I called this one long because I spread it or gathered it from a wide data set to a long data set, reshaping wise. So we're going to say long equals, what was my example? So this is an example if you want to drop a specific number, you just make it like a negative uh, number. So we are looking at this, we want to drop 1, 2, 3, 4, 5, 6. We want to drop 7, 8, 9, 10, 11, 12, and 13. So 7 through 13, actually. So we can do it this way, I think. Let's try that. Nope. Um, mhm. Okay, so it's saying do it this way using select. Let's try that instead. If you're doing just one column, it's easy to do it with the index number, but let's try it this way. Long equals select minus, so dropping columns 7 through 13. Okay, so now, yep. Okay, so that's a lot cleaner. I mean, we still, let's see, what's this GWP variable? Do you know what that is? Jaime, did you look at the data dictionary?
Sorry, I didn't think I was muted.
It's all just ones, right?
Yeah, it's all ones, and then the units are also the same for all of them.
Okay, so 13, 12, 11, 10. I'm going to drop column 10 by using the specific index just to show y'all that that does work with one column. So long equals. Whoops, I just messed up. Do you know what I did wrong? Anybody catch that? I accidentally deleted rows 7 through 13 again. of the new data. So let me re-upload. Oopsie. Okay, now we're going to do this filter again. And then we're going to reshape it again. And now I'm going to run this one time and drop column 7 through 13. And then after that, it will drop. Let me just pull this out to a new chunk just to make it clean. That goes down to 13 variables. Now drop column 10. Okay, so now we have this clean data set. We have all of our X values, all of our one column with all the years, one column with all of the values. It's all carbon dioxide, and we have it broken down by state and by sector. So now let's work on the plot. Multiple line plot with lines for sector. X is year, Y is value. That's what we called it, right? Value. Okay. So we're going to say plot, I'm just going to call it 5, because I don't know what, I don't think I've done 5 yet, equals ggplot, data equals long, this new data frame that I've made, aesthetic mapping, X equals year, Y equals value. And then we want to add color equals is it color or is it fill? To refer to the graph gallery. Color. Okay. So group equals econ underscore sector.
Yes.
Color equals econ underscore sector. And then we are going to add geom point. Let's see if that works. Whoa, that's I don't know why I did a point instead of a line. Y'all could have told me I was messing up, but it does look interesting with the dots. Let's see what it looks like as a line plot. Sorry about that. Woo! What on earth is this? Okay. That's weird. Maybe we need to, let's just see if we do just the values, what this looks like. What is going on?
Yeah, when I first tried the graphing, I didn't know what like the data was supposed to be formatted like, and it just spat out like 8 different graphs of like different lines.
Mm-hmm. So our value is a number. We've got our year as a character. We might want to change the year to a factor and delete the Y just for cleanliness. We can do that. And then it's looking like, do we have in this, so it says the units, they're all TG. The georef, why are there 63 geographies? Do you know?
I'm not sure.
So we
I
have,
was I was thinking of like doing only 2 states,
okay, which ones?
Wyoming and Vermont.
Okay, so we have US territories as one. Okay, I'm just trying to figure out why there's 63. It must be UM.
Maybe that's Canada.
It should be in the data dictionary, but yeah, okay. So, I mean, that looks pretty wild, this chart. So I'm thinking first, let's go ahead and do the thing. Let's clean up the year value. But I think we need to delete the Y from the column before we convert it back to a factor. So delete one letter string R. Yeah, G sub. Okay, that's so you can use this is another part of the grep text packages that come with the base version of R. It's called G sub, and it can substitute out a string pattern for any strings or characters in a column. And so basically what you do is tell it the pattern that you're looking for, the replacement that you want it to replace it with, where it's looking. So what we're going to do is say long year equals, we're going to override it, and we're going to say G sub. The pattern we're looking for is a Y, right? Is it capitalized? Yep. So we're looking for a Y. We want to replace it with nothing. So I'm using empty quotation marks. So it's just going to delete the Y out of these. And then where we're having it look is the same column, year. And I don't think we need to add any other parameters. So let's see if that worked. Yep, so now we just have the nice, the clean year values. Let's go ahead and convert that to a factor. So long year equals as factor, long year. All right, so now over here I see that our year has converted into a factor. So now we have our factor year and our value units. Let's look at really quickly. One continuous variable, one discrete variable. These are the plots it's telling us to look at. And my doorbell has rung. Okay, so here's what we're gonna do. I'm gonna pause for a second.